Okay, so we covered pretty much everything I wanted to cover with respect to file I/O, but I did want to get a little bit more practice so that you have some more practice as we go on, and of course, this is going to be a transition into the next module that we have. Just making sure that everything works here, especially because we've been having problems for the last week or so. All right, so what I want to do is an exercise here that not only do I want to read in an entire file and do some file input, but I actually want to process it. So this will be a review of what we've been doing for the last couple of weeks, both on string and data processing, as well as file I/O. So, yeah, we're good. All right. So what I want to do is I want to write a program that will read in books.csv, process each line, and pull out the title, the author's first name, their last name, the year that it was released, and then finally the Goodreads rating for it. Okay, we'll just use this data, right, and that data formatting. So let's go ahead and open up the file first of all. So what should I do here? Well, let me go ahead and define the file name here in a variable, right? So file name, and I'll just hard code that value to books.csv, and I'll assume that it's in the current working directory. Another way of doing this is by putting a period then a slash. That's the current working directory and then a /. This is a directory up and then the books.csv file in there. This is one directory up and then down into the foo directory, and then you look for the file there. Just keep it simple and leave it like that for the current working directory. Okay? So help me out. How do I open up that file for, say, reading, because I want to do file input? First thing I do is a file pointer. Right? You can call it input. I'll just call it f. Right? What's the function that I use to open a file? Open. Good. And it takes two arguments. The first one is the file name that you want to open. Well, normally if I want to hard code that, it would be books.csv, but I've already put that into a variable up here. So let me go ahead and use that variable, file name. Right. What's the second argument? The read or write. And I'm going to be doing file output. No, this file already exists. So I will be doing file input and reading this file. One thing I like to do is immediately close my resources. In other words, I'm going to be processing it, but before I write that processing code, don't forget to close your resources. So immediately after you open something, immediately close it. Right? And then go back and write the code that actually is responsible for reading this file. Again, failure to close may lead to corrupted data, unexpected results, undefined behavior. So always just do it. Okay. All right. What next? Do I want to read this character by character by character? Probably not. Character by character by character would be forget C, F get a character. I want to use something else. If I want to read it line by line by line, because each line is a record, each line is a book record. What's the other tool that we should use? F get S, or forgets. Okay. Remember that it takes three things, A, B, C, right? Three things. The first thing is what? The buffer, char buffer. And I'll just make it, I don't know, 1,000, right? That's big enough. Do you see any lines over here that are more than 1,000 characters? No, that's good, right? If we did have a book that was more than 1,000 characters long in its title or something like that, then we would have a problem, right? At that point, we would need a little bit more sophisticated tool to do this. But at that point, I would be bringing in a library to do it anyway. Right? 1,000 is good enough. If that's not good enough, 2,000 certainly is. Right? 2,000, 1,000 is good. Right? I'm going to read into that buffer the results of up to 1,000 minus 1. Right? It will do the minus 1 automatically for me. Oops, come on. Right? So why is it minusing 1 here? The null terminating character. It will automatically put it in there. So this can actually read any line that is 999 characters long, because it needs room for that one null terminating character. Right? And then the last argument is the file that you are reading from. Okay? And I just called that F up here. What's that return value? What does it return? Does it return an integer? Success? Failure, right? Some flag value that it gets stored? No. What does it return? A. Well, no, it does return something. Or F get C returns a single character, an integer, right? But what does forget return? S. Char star, right? And I'll just call that line because that's what it is, right? Because I want to go into a while loop. While line is not equal to null. Oops. Remember with F get C, right? It was the EOF character, that end of file character. But with fgetS, when you're getting an entire string, an entire line, you need a different way of doing it because there is no end of line character. Well, actually, there is an end of line character, but it is retained in that string right there. Right? So while it's not null, I'll go ahead and, for now, let me just print it. Printf, a line is equal to %s, and the line, and I will print the buffer. Right? Buffer and line are basically the same thing at this point in the program. Right? Then I will set myself up for the next iteration by calling forgets again on the exact same parameters. Right? Let's see if that works. GCC demo.c. Okay, let's run it. A.out. There. So let's start at the beginning here. The first line is 20. The next line is Harry Potter, ... And then we've got a whole bunch of blank lines here. Okay? I also see that it's double spaced. Let's take care of that first. Right? I don't want that end line character there. How can I get rid of that end line character so that it doesn't print? Before I print it out, what should I do? We called that operation chomp. How can I chomp it though? If the last character in buffer is end line, then remove it. Okay? So how do I change that if statement into an actual C if statement? Where's the last line of the last character in a string? Buffer sub strlen hello 5. It's 0, 1, 2, 3, 4. So strlen of buffer -1. If that is equal to the end line character, then chomp it out. How do I get rid of it? Make it a null terminating your character. There we go. 0. Right? This protects me. What if it's not an end line character? Right? What if it's... I didn't read the entire line. I read only half the line because it's 2,000 lines, characters long. Right? This protects me from that possibility. Then I remove it. There we go. Right? Then let's go ahead and make sure that that worked. Good. Now I'm getting 20 Harry Potter ... I'm still getting a whole bunch of blank lines that I do not want to process. So one thing I could do is, instead of printing it out if it's empty, I could check if the string buffer is empty, ignore it. Right? ... So let's try that. Otherwise, else, print it. And then we'll simplify the logic here in a second. All right? Regardless, get the next line. If the buffer is empty, ignore it. In other words, do nothing. Do nothing. ... How do I tell if a buffer is empty? Well, a buffer is a string, right? I want to know, is the buffer equal to the nothing string? The string with nothing in it. Is that how you do equality with strings? Nope. There's this other tool that we introduced. It's called, if you're working with strings, it's going to start with str. And it's a comparison, so it's CMP. Compare that buffer with that string, and if they're equal, then it should return a 0. Remember, it returns something negative, positive, or 0, depending on the relative ordering of those things. So let's see if that works. There we go. So all those blank lines are now gone. Why didn't this one go away? Let's take a look at what's in that file. I will highlight everything. It's really, really faint. Maybe you can see it on the live stream here, but there's a tiny little dot there. That's highlighting the space that's right there on line 28. There is indeed a space. That's not blank. So how could we take care of that? Write a function. Maybe is blank, int is blank, right? And it takes a const char star str, and I won't write it here, but I will document it because, gee, I really wish that I had that. right? It returns true if the given string only contains white space, right? False otherwise. Right? So I trust everybody here could write that as an exercise, right? How would you do it? That C-type library, right? If you find anything that is not space, remember, is space, right? I don't have man pages on this, but is space C-type, right? That will return true if it's a space, if it's an end-line character, etc., right? There's a space, new line, horizontal tab, vertical tab, form feed, or carriage return. Right? So you could very easily write that function if you wanted it. All right, so I'll leave it like this for now, though, because what I'm going to do is I'm going to take another approach here entirely, okay? Let's take a look at that data again. Look at that first line. Why did we put that first line in there for, giving this data? Why did I put that first line in there for us? What is that first line doing? 20. There are how many lines in there? 21, right? So how many records are in there? 20. Why are we ignoring some free information that you're giving us? Let me go back and rewrite this loop entirely, right? So I've read the first line. Read the first line, right? What is that first line? 20, right? If I add a book later on, I'll come back and I'll update that to 21. If I add another book, I'll update it to 22. Right? For now, I'll keep it 20. Right? How do I get the number of books, which is an integer, is equal to, can I do this? Oh, here, buffer. I'll keep it like that. The thing on the left-hand side is an integer. The thing on the right-hand side is a string. So, a string that contains 0. How do I take a string that contains a number and transform it into an integer? A to I from the first week. Right? So, A to I of buffer. Right? Excellent. Now, why did we do a while loop in here to begin with? Because we didn't know how many lines were in the file to begin with. But now, it doesn't matter how many lines in the file are there. Right? That first line is telling us there could be 1,000,000 blank lines. Only read the next 20. What kind of a loop do you want to do now that you know up front how many lines that you should read? Okay, for loop. I is less than num books, I plus plus. I'm only going to read the next 20 records. If I come back and add a record, as long as I update that number, it'll still work. Right? It'll end up ignoring all of those other blank lines. And all that looks good. Let's go ahead and try it. I think. Yep, there we go. So, oops. 20. That doesn't look like the last one, is it? Raising steam. Did I put that last? Nope. Oh, good. I'm glad that happened. All right. Because I rewrote this as a for loop, let's think about the status of this program right here. I read the first line, right? It's gone now to the second line, right? I'm going to read the next 20 lines. What's the first thing I do, though? What's in the buffer right now at this point on the first iteration of this loop? 20, 0, and then the end line character, right? With the while loop, I went to the next line at the end of the while loop. Where do I want to do that now, though? At the beginning. Right? If you wanted to, you could have done this, and then you'd be off by one still, but I'll do it right here. Right? So read the next line. If the character in the buffer is the end line character, chomp it out, right? And then print it. There we go. We were off by 1. There. Now, A Game of Thrones is down at the bottom, and Harry Potter is at the top. Right? Wonderful. Oh, I forgot to close the file? Nope, I did it. Why? Because I did that when I wrote the fopen command. Right? All right, now let's take the next step. Instead of just printing it out, let's actually process the data. At this point in the program, we have something that looks like this. Right? Now, I want to tokenize that. I want to split that up into the title. I want to split that up into the author's first name, last name, et cetera, et cetera. Right? So you did that yesterday in your lab, right? MLB teams or whatever it was. But instead of commas, you used a space. So help me out. How do I get that first token? STR, what was it again? Toke, right? And I need to tokenize the buffer, and I'm going to use the comma as my delimiter. There we go. Remember that returns a string called token. There we go. All right. In fact, the first token is what? What should I name that? It's a title? Okay. Let's try it like this to begin with. Title. All right. Char author first name is equal to. Now the next time I call str toke, how do I call it? Do I pass in buffer and then the same delimiter there? Nope. Every subsequent call it's going to be null. Right. Copy paste, copy paste, copy paste. Last name, and then that takes me up to here. Is that a string? Technically it's a string, but how should I represent that? It's a year, right? So our years halves 2007.5. Nope. An integer. How do I convert that integer? I did it above once, a to I of str toke of null, and then same delimiter there. Right? And, I need to give it a name. Year published. There we go. That's a descriptive name. Should I have gone with Y instead? That's a terrible variable name. Should I have gone with year? That's a little bit better. Even better, though, would be the year that it was actually published. Okay? And then the Goodreads. That's obviously going to be a double, right? And I'll just call it rating here. It is actually Goodreads ratings, but I'll just go ahead and leave it as a rating. Now, it's not A to I. What is it? A to F. Of str toke of null. All right? There. Let's see if it crashed or not. Double rating. Oops. There we go. Doesn't compile. There we go. All right. It works. All right. But I don't know if it's working. Let's go ahead and print something out now. Printf. Let's go ahead and go with the title. Let's format this really nicely. Right. We'll go ahead and format the title. In fact, I'll put a 20 in front of it so that it aligns everything nicely. And I'll align it all the way to the left. Right. I will then print the author's last name, comma, first name, right? Because that's how authors are usually represented. Burke, comma, Chris, right? Rowling, comma, J.K., Herbert, comma, Frank, right? All right, and then, I don't know, maybe in parentheses here, I'll put in the year, %d, because that's an integer. And I will go ahead and output the rating here in percent point, let's go with 5.2f. Right? What is that doing? At least 5 columns, right? So if 5 columns, including the period, so two decimals of accuracy, the decimal point, and then that'll give me a space right in front of it, right? That's nicely. That's a nice representation there. So the title, author name, author last name, author first name, and the year published, and the rating. All of those will now get printed in that nice new format. Much more human readable now, right? Oh, do I have a comma in there somewhere? Oh, I didn't want that comma. All right, there we go. Ah, cool. Everything almost lines up, except that I've got a very long title here, so maybe 20 wasn't great. Let's go ahead and go with 40 instead. There we go. There. That's more than enough room. Right? Maybe I want to align all this, all of these. So do that somehow, right? Just get it looking really, really nice, right? I don't want to focus on that for now, though. What I want to focus on is, at this point, after I've read all the data, what I want to do is print the title and author and year of the best book. In other words, the highest rated book. Highest rated book. Can I do that at that point in the program? I opened up the file, I read it all line by line, I split it all out so that I can actually find the rating here. Right? I could keep track of the highest rating. Let's do that. Double highest rating. I'll initialize that to something. And then once I've got the rating there after I printed it out, if that rating is greater than the highest rating so far, then I'll update the highest rating. Highest rating to be the rating. All right. And then down here below we can actually print that. Printf highest rating is %f and the line highest rating. Tell me, what should I initialize that to? 0? Well, it's on the 0 to 5 scale, so yeah, you could do that. What if I did this 5? Is there going to be any book that is higher than 5? No, that's the perfect rating, right? None of those books are 5s. What's another, maybe even more sane flag value that I could have? Something that no book will have as a rating, but that I'm guaranteed that all of these values are greater than it. It could be 0. What's even safer? -1. Everything is going to be higher than that. If it ends up being -1, I know something went wrong. That is a good flag value, initialization flag value. Right. Let's run this again. See who is the highest rated book. 4.62. Does that tell me anything? It tells me what the highest rating is, but does it tell me which book it was? I can come over here and go 4.62. Oh, apparently it was, oops. Whoa, okay. As it reloads there, it shouldn't take long. It was that first book. There it is. All right. But does that give me the title? Does that give me the author? Does that give me the date? No. So, let's come back over here and rethink what we're doing. What am I going to have to do if I want all of that data? Every time I update the highest rating, what will I need? I will need a character title of the highest rated book. Anytime you find yourself typing out a variable name like that, it's a huge red flag. Probably doing something wrong, right? But in addition, what else will I need? Char, author, first name of the highest rated book, right? Char, author, last name of the highest rated book. Int year published of the highest rated book. Right? Now, if I were to do this, I would have to update all 4 of those variables. Right? Anytime I find a new highest rated book, I have to update 5 pieces of data. Right? Does that sound like a winning strategy? Probably not. And in fact, if you take a look at a deeper look at your lab yesterday, an MLB team really only had 2 pieces of data for that exercise, the name and the win percentage. Look real closely at the function that was used to sort that. Anytime you found an MLB team with a team with a higher rating, you had to move them up to the top or something. What else did you have to do? You had to take the team name and move that correspondingly over here. If you found one with a lower rating, you had to move them down here along with their title. That was only 2 pieces of data. And I believe that there were at least 40 or 50 lines of code for that. Imagine if I were to do that with 5 pieces of data, 6 pieces of data, 7 pieces of data, right? No. So let's rethink this all the way from the beginning, right? Built-in primitive types like this, integers, doubles, characters, they're very limiting. right? If you need to keep track of all 5 of these things, all 6 of these things, all 7 of these things independently, you need an array for each and every single one of them. That's not reality, right? Reality is that things in the real world are made of multiple pieces of data, right? And in a programming language, programming languages, you can collect and encapsulate multiple pieces of data together into one logical unit. In other words, instead of defining 2 variables, a winning percentage and a team name to define an MLB team, I should probably define an MLB team that has these 2 pieces of data into one logical thing. So that when I have an MLB team that needs to move down here, I move it along with all of its data. When I have a book that needs to get updated here for 5 pieces of data, I don't update one of those pieces of data and then the other 4 along with it. I update that one thing. Right? The solution in C is going to be structures. In C, this is achieved using structures. Right? So structures support what's called weak encapsulation. Encapsulation in general is the following 3 things. The grouping of data, there we go. The grouping of data, the protection of that data, and the grouping of functionality that acts on that data. Now this is an old concept because of course it is supported in C, but it's only supported weakly, right? C, or generally, I'll say, OOP languages, that is object-oriented languages, all object-oriented programming languages, support all 3. In other words, strong encapsulation. However, C is not an OOP language. In fact, it predates object-oriented programming paradigm. C came along and then they decided, wait a second, why don't we have this strong encapsulation here with all 3 of these things? That's a pretty neat idea. All right, great. I'll go ahead and add that on with what are called classes, and then you have C with classes. That's too much of a mouthful. So what did they call it? Bjarne Stroustrup call it C++. Right? Plus, next language. There was another group of people that thought about the same thing, but they wanted to make their own language. So I want to add object-oriented programming principles to C. I'll call it Objective-C. Right? And that's how you get Objective-C. That was the programming language default of iOS up until they made Swift, because nobody wanted to program in Objective-C anymore. Right? That's why you have C#. Right? It's why you have all this explosion of object-oriented programming languages in the late 80s and early 90s. Right? Unfortunately, with C, it's not an object-oriented programming language. Fortunately or unfortunately, there are people that hate object-oriented programming paradigms. Linus Torvalds is one of them. Several others, I don't care, right? One way or the other. OOP has a lot of really cool things. C has a lot of really cool things. Python has a lot of really cool things. And by the way, all 3 of them have all really terrible things as well. Right? I always quote, I steal a quote from Churchill whenever somebody asks, what's the best programming language? So Churchill was asked, what's the best form of government? And he replied by saying, democracy is the worst form of government, except for all the others. So C is the worst programming language, except for all the others. In other words, there's no such thing as a perfect programming language, right? Right. So C is not an object-oriented programming language and only supports number 1, right? The grouping of data into one logical unit. We do not have the protection of data. We do not have the grouping of functionality that acts on that data. Right? You'll see that when you look at your first object-oriented programming language, say like Java next semester, if you're doing that. Right? All right, so how do we define these things called structures? Well, let's go ahead and start, just in the notes here, with our first attempt. I need a book structure. Right? So let's go ahead and let's create a structure that models a book. All right. Dot, dot, dot. All right. To create a structure, we already have that syntax. Type def. Where have we seen that before? Type def. Definition. Where have we used that before? Enums. Enum. Type def enum, and then we open the closing curly bracket here. We're not defining enums. We're defining structures. So what's the abbreviation of structure? Struct. Right. We need to give it a name. Just like we gave an enumerated type of name, error code or whatever, we need to give this a name. Right. Suggest a name there. It models a book, so what should we call it? A book, right? Not all naming is hard, right? Just name it what it is. Name it what it represents. Right? Note here that I am using upper camel casing, right? Generally, the modern convention is to use upper camel casing for your structure types, right? Why? Because eventually you're going to want to create something like this. I want to create a book, and I can call it B. Sometimes I'll call it book, right? Now, how do you know which one is the type, and how do you know which one is the variable name? Because you're following a modern convention and you're being consistent about it. Upper camel casing is going to be the type. Lower camel casing is going to be the variable name, right? Why didn't I call it books? I'm going to be defining multiple books, right? Books, plural, tells me that it's an array of data, that it's a bunch of books, not one of them. Right? This is one. Right? So inside of this structure, we then now define what a book is. You tell me, what is a book? Pretty straightforward, right? At least for this data. How would you define a book? A book is going to have a title, right? Which is a string. Note what I put at the end there, semicolon. If this were an enumerated type, it would be a comma because that's a list. This is not a list. It is a collection of variables. It's not a list of variables. Title, what else? All right, char, author, first name, char, author, last name. I'll beat you to the punch there. What else? Year, okay, so int, publish year. All right. And finally the rating, which is double. There we go. I've taken those 5 pieces of data that were, just hanging around in the ether here, and I've now collected them into one logical unit, book. You can create a book like this. You can create a pointer to a book, right? You can do a whole bunch of things. Before we get there, though, we need some refinement here. Right? This is good enough for an initial design. Right? Generally, by the way, structure declarations are placed into header files, often of similar name. So if I were doing this, where would I put it? I would put it in the book.h file. Right? Put it in a header file with the same name. Right? Okay. You generally need to document it. Generally, you should document them. ... So let me come over here and do that now. Let's go ahead and create a new file called book.h. There we go. And I'm just going to cut and paste this over here. Yay. That's our first initial draft. And I will go ahead and document it with nice doc style comments here. Represents a book. That's all you need, right? Some things are self-evident. Right? But now let's go ahead and refine this a little bit. Title, I buy that. Author's first name, author's last name. That sounds like 2 pieces of data to me. Maybe the author has a birthday. Maybe the author has a middle name. Maybe the author has a title. Maybe the author has a social security number. Maybe the author... ... right? I should have stopped at 2. Anytime you find yourself with something that is represented by 2 or more pieces of data, what should that be screaming out to you? Make a structure. Right? So, before we continue, let's make an author structure. Right? So type def struct author. Right? This is called composition. In fact, I'm going to move these two things down there. Right. There we go. That a book is composed of multiple pieces of data. An author is composed of multiple pieces of data. How do we get it so that we have an author then? Author. There we go. There. A book is composed of an author, among other things. An author is composed of two strings. And that other stuff that I mentioned if you want to throw it in. Social security number, whatever, right? Composition. It allows you to separate these things. In fact, what I would do is I would take away the author prefix there and just have first name, last name. Right? Now, that's more general than an author, isn't it? What is it? Anybody, right? Person. That means that instead of author, I'll have a person, author. Right? Now it's looking way more like plain old English, isn't it? Right? Why? Because we are modeling the proper real-world objects with our code here and proper naming and proper design. Right? Publish year. Okay. If you're only interested in the year, that's fine. That's enough. But when was, I don't know, when was Dune publish date? Dune publish date. Right. Oh, come on. 1965, I knew that, but what year, what day? August. So I'm not going to get the day, but at least I got the month. All right? Let's come back over here and really think about that publish year. What if I wanted all those things? Well, year is an integer. What if I want the month? What is that? Oh, well, hold on. Yeah, what else? What is the month? An integer, okay. But it's an integer, is it 1 to 12? Or is it 0 to 11? Yeah, that sounds like an enumerated type to me. Right? So maybe I want to do that. I'm not going to go that far. What about the day? Right? That's 1 through 31 sometimes. Other times it's 1 through 30. Other times it's 1 through 29, like next year. That's the only date that it would be February 29th or 28, right? Seems like a really complicated problem. But 1, 2, 3. 3 pieces of data. What should we do? Put it into a structure, right? So type def struct. And at that point, you bring in a library to do it. Don't worry about dates, right? And I'll call it a date here, though. It's no longer publish year. What is it? Year, month, day. All right. Let's go ahead and try to compile this now to do the rest of those documentation. Right? I'm going to bring it into my demo up here. It's a user-defined library, so what should I do? Include, double quotes, book.h. Good. GCC this, and it's going to fail. I don't know anything about person. What is a person? Let's be a dumb compiler for a second. Right? We're all smarter than a compiler. But let's think like a compiler. Right? Okay, type def struct book. All right, you want to define a book. Oh, char star, that's a string. I know about that because it's built into the language. Person, what the heck's a person? Do we have any information on what a person is here? No. That's down here. Int x, int y, int z. The order matters. If you are going to have a structure consisting of another structure, the order matters. You need to define the person first, and then... Oh, I forgot the date, didn't I? Date, publish date. Right. So if I have the published date of the book here, where does this date declaration need to be? Above it. There. That will now compile. There we go. Because it's in order. You know what? I want to redesign my person structure here to also have a date. Date of birth. There we go. We want to know how old the author was when they were published it, right? We want to do all this kind of weird data analysis, right? That's not going to work. Why? Again, a dumb compiler sees person, date of birth, what the heck is a date? I don't know anything about that. So this needs to move where? Above the top. Now it will compile. I like that design a lot better. Right? So order matters. Let me go ahead and replace our design over here with one that actually works. Right? So generally you should document them. The order matters if you use composition. Right? Composition is just simply that one structure may be composed of other variables and structures which may be composed of others, etc. Right? Think of it like what are those Russian dolls? Small doll, and then the bigger doll, and then the bigger doll, and the bigger doll. What are they? Okay, well, I'm just going to call them nested dolls. I'm not going to pronounce that. Whatever that is. Let's come over here now that I've got internet, and let's take a look at what Python Tutor visualizes this as. So let's edit this. I will put my declarations up here as if they were in a header file, and then I will create a book B. Right, there we go. Let's visualize that execution. There's my book, right? B. What does it have? It has a title, an author, and a publish date. That publish date is another box. In that box, we've got year, month, and day. Author is another box, this big box over here, that has a first name, last name, date of birth. Date of birth has another box in it, right? So these Russian nesting dolls, or nested dolls, right, where you've got one within the other within the other. Right? That's composition. Now that we have this, we can start using it. Right? So, structure usage. You can, once defined, you can use a structure like any other type. For that, I'm going to move that code down here. There we go. Right. To access the member variables, right, that's what they call them, member variables or components, use the dot operator. Right. So what do I mean by the dot operator? Let's go ahead and set something here. There's my book. Book dot rating was equal to 4.62, something like that. I've got a book. How do I get the rating of that book? It's the dot operator. Technically, that's called the direct component selection operator. Right? Who's going to say that? Right? What is it? It's a dot. That's why we call it the dot operator. Right? All right, well, great. I can now start building a book for J.K. Rowling here. Let's choose a better book. Not to impute. I was around a whole bunch of Harry Potter fan children yesterday for Halloween, so I would not want to make anybody mad. I don't know. Neuromancer instead? That's good. So, Neuromancer, William Gibson, 1984. Right? Let's go ahead and set his rating to 3.88. It could be better. It probably is better. How do I take care of that title, though? Book.title. Can I do this? Neuromancer. Right. Is that how you copy strings? No. That will not even compile, I believe. Right? Hopefully it won't compile, or at least at the very least it'll compile with warnings. Right? What do I need to do in order to create a string that holds Neuromancer? First thing I need to do is call malloc to set up enough space for it. Right? So size of char. How many in there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? Is 11 enough? Nope. What do I need? 12. So 11 plus 1. Why? For the null terminating character. After I've done that, I can do strcpy into book.title, Neuromancer. There we go. There. Same thing is going to happen all over the place. Author's first name, author's last name. Anytime I have a string to do this, I'm going to be copy paste these two lines all over the place. Right? There's got to be a better way. What if I go back to a lab or a hack or one of the lectures and realize that deep copy function, that deep string copy function that we wrote, that seems so damn handy, I'm just going to cut and paste that everywhere and reuse it everywhere. And you should. Right? I'll leave it like this, though. Right? What about that author? Book dot, remember, it looks like this. Book dot author, all right, well, that's a person. How do I access their first name and last name so I can copy in William Gibson on it? Book dot author dot first name, right, is equal to a call to Malik char star Malik. And I'll leave it as dot 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 for now because we're going to improve this even more. Right? And then I will go strcpy into book dot author dot first name William. And I won't worry about this, the last name because we're short on time. But look what I did. Dot dot. Right? The book is one of those dolls, right? Where is it? One of those Russian nesting dolls, right? There's book, or B in this case. How do I access the author? B dot author. How do I access the first name within that? I need to keep going inside the box, inside the box, inside the box. Dot 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 dot. Right? I would do the same thing for their birth date if I was so inclined to set it. Right? That's just a preview of what we'll do here. Man, that's a lot of code, and we're not even halfway there of creating this thing. Right? I'm probably going to want to do this 20 times for this data alone. If you find yourself doing something 20 times, what should you do with it? Put it into a function. What if I had a function that looked like this? It was, I don't know, create book. Right, there we go. And I'll just put the header file in here. And it took all the data that you wanted. Say the title, const char star title. Right? Const char star author first name. Const char star author last name. And int publish year and double rating. Right, there we go. That can get quite long. Here's another alternative way of writing these kind of things. Put one parameter per line. Right? And then you've broken up a really long line into a series of top-down lists. This is perfectly fine. Note what I'm doing here. I'm aligning everything on the same column, though. Right? So when we come back, we will design this function. But before I do, what should it return? A book? Book. We can do it that way. An even better way is going to be to use what we've learned up to this point and not return an entire book, which, by the way, how big is it? Big. There's 8 bytes. There's 8 bytes. 8 bytes. I'm up to 24. There's 4 bytes, 4 bytes, 4 bytes. That's 12. So I'm up to 36 bytes. Another 1, 2, 3, another 12. So what am I up to? 48. And then finally a rating, which is 8 bytes. 56. 56 bytes. Not that big of a deal. That's not going to break the bank. But it's much easier to return 8 bytes and only return a pointer. Right? Cool. We'll do it that way. Oh, somebody wrote it. Matryoshka? Matryoshka?